All right, so here we'll be looking at how to express these functions. If we have a linear combination, if we have a sine x plus b cosine x, it can be written in the form of what? K sine x plus alpha. As you can see, this is true, where k is what? The root of what? A squared plus b squared, and alpha is the angle between is the angle for which cosine alpha is equals to a over k. So let me just give us a quick illustration of how this happens. Now, this is what we have. We have a sine x plus b cosine x. So when you want to prove, we always look at the goal. So it's like an identity, right? So we have the left-hand side. So we want to prove that consider this as the left-hand side, and this is equals to the right-hand side, right? So this is what we want to show. Now, if we look at this, we see that the right-hand side is in terms of sine. But here you have sine x and you have cosine x. So the only way we can have this to become sine is if we relate our a to be something that has to do with what? With cosine, and we relate b to be something that has to do with sine. Then we can use the sum formula to bring it back to sine. All right. So now this we can write as what? Now let's consider a. Since I know a has to be related with cosine, let's look at this now. You have a point. Let's take a point that has to do with a and b. You can, let's say, in the first quadrant, just for example. So we know that the point A is going to be related with what? With cosine. And the y coordinate is going to be related with sine. So let's call this alpha. So clearly it means that you can see that what is cosine alpha? Now, the hypotenuse, which is k, this is going to be root of a squared plus b squared, right? So it means that cosine of alpha is going to be a over what? Because remember, a is the x coordinates, and b is the what? Is the y coordinate. In other words, this distance here from here is a, and this is b. So we can easily say from here that cosine alpha is what? Is adjacent, which is a over the root of a squared plus b squared. Okay, so which we can just say it is cosine of alpha is equals to a over k. So what is k? K is the hypotenuse, which is the same thing as the root of a squared plus b squared. Now, the same way, we can easily see that what? Sine alpha is nothing but b over what? K. Now, with this in mind, we can rewrite this as what? So I see that anytime I have a over k means cosine alpha. Remember, I want to write this a to be in terms of cosine, yes? So you can see. So what is a from there? What can we see that is a? From here, you can see that a is nothing but what? K cosine of what? Of alpha. Also from here, we can see that what? B is nothing but what? K sine what? Alpha. See? Now, if we get back here, so instead of a, what do I write? Instead of a now, we'll write k cosine alpha plus, instead of b, okay, no, not done yet. Remember, here we have k cosine alpha, then we have sine x, yes? Plus, what is b? B is k sine alpha. Then we have cosine of what? Cosine of x, right? So this simply means that we can take k as a common factor so that we have cosine alpha sine x plus sine alpha cosine of x. See? So what is this? This is nothing but k, but if you look at this, from here to here is nothing but sine alpha plus what? Plus x, which we can write as what? Sine x plus what? Plus alpha. So this is what we have proved. And now this is the what? The right-hand side. Okay. So in a nutshell, so therefore, anytime you have a sine x plus b cosine of x, we can write it as k sine x plus what? Plus alpha. But don't forget, what is k? K is nothing but root of a squared plus what? Plus b squared. All right. Okay, so we will see how to use this. We'll see how to use this now. Okay. Oh, we can. Now, to get k is very easy, but something we need to check is how to find the what? How to find the alpha. Okay. How do we find the alpha? We're going to discuss that shortly. Now, to find the alpha, we will need to use these quadrants, this chart here, which we will discuss later. It's just like the reference angle chart. So here we'll use alpha is what? 180 minus alpha star. Alpha here is 180 plus alpha star. And here is 360 minus the alpha star. So we'll take example and we'll demonstrate with that. So look at now example 8. Example 8 says you should write the function root 3. So this is the function now. We want to write this root 3 over 2 sine x minus half cosine of x, right? So we want to write it in the form of k and what? X plus alpha. So we need two things. We need to find k and we need to find alpha. So always take the coefficient of what? Of sine x to be your a. So a is root 3 over 2. And then we can take b to be the coefficient of cosine, which is minus 1 over 2. Therefore, k is going to be root of a squared plus what? B squared, which is going to be a squared is what? If you square a, we will have 3 over what? 3 over 4 plus b is going to be b squared is 1 over 4, right? So it means that k is the root of what? Root of 4 over 4. It's just root of 1. So clearly k is equals to 1. Okay. But one thing again, here we should mention this one. Oh, it's clear. Look at here. We saw that what? Cosine alpha is a over k, right? And sine alpha is b over k. So we have to mention that here. Cosine alpha is what? Is a over k, which means that cosine of alpha is what? Is root 3 over 2 divided by 1. Also, sine alpha is b over k. So sine alpha is, what is b? B is minus half over k. So this is just what it's going to be because k is 1. All right, now it means that this is equal to k. We know what is k, 1, yes? Then now we have sine x plus alpha. So we need to know what is this alpha. So from here, cosine is positive either in the first or in the second quadrant. Sine is negative. It's going to be either in the third, right? Yeah, sorry, cosine here should be either in the first or in the what? The fourth quadrant. Not cosine inverse, but cosine. And sine is negative either in the third or in the what? In the fourth quadrant. So we're going to take which quadrant is common. So the common quadrant here is quadrant number 4, right? All right. So we're going to use the chart now. But before we use the chart, we need to find our reference slash. So it's like a reference angle in the first quadrant. So we need to find what is alpha star. Alpha star is an angle in the first quadrant whose cosine is what? √3, and whose sine will give us what? Not minus, which will give us half. And that angle is pi over what? Pi over 6, right? Yes. Because if you have pi over 6, cosine pi over 6 is what? √3 over 2. And sine pi over 6 is going to be 1 over 2. So don't worry about the minus here. This minus here have been taken care of. So, but since we are in the fourth quadrant, it means we will use alpha to be what? 2 pi minus what? Alpha star. So now we're using the chart. This is the chart here. So this is alpha star. If you're in the first quadrant, in this quadrant, alpha is what? Alpha star. In the second quadrant, you have 180 minus alpha. And then here you have pi plus what? Plus pi star. But here we'll use this. So it means that your alpha is actually 2 pi minus pi over 6. And this is going to be 11 pi over what? Over 6. So if we go back here, it means in the position of pi, of alpha, I mean, we will just substitute 11 pi over 6. So this is our equation. Now, from here now, we can find so many things. We can find the maximum value. So what is the maximum value? The maximum value is just going to be 1, because remember the range is going to be, what is our amplitude? Our amplitude A is 1. So the maximum value is just going to be 1. Yes, because there is no vertical shift. And the minimum value is going to be -1, because the range, remember, range is given by what? Minus absolute value of A to this, which is just -1 to 1. Okay, then what else? We can find the horizontal shift. So the horizontal shift, Hx, is nothing but x is equals to what? Minus b over k. And this is just going to be minus 11 over what? Minus 11 pi over 6. And then we just sketch the graph. We already dealt with a lot on how to sketch the graph. You can check 6.3 for that. So this is the equation that we finally got. All right, so let's take another example, similar example, example 9. This is directly from old exams. Now here, just like we said, always take A to be the coefficient of X and take B to be the coefficient. A to be the coefficient of sine X, B to be the coefficient of cosine X. So A, in this case, is -3. B is also -3. So what is K? K will be the square root of -3 squared plus -3 squared, which is square root of 18, yes? And this will just be what? 3 square root of 2. So this is k. And we know that cosine alpha, but now we cannot use, cosine alpha is what is a over k. So cosine of alpha is a, which is minus 3 over k, which is 3 over 2, right? So it means that cosine alpha is just going to be minus 1 over root of 2. In the same way, sine alpha is b over k, which means that sine alpha is minus 3 also, because b is also minus 3, right? So sine alpha is going to be minus 1 over root of what? Root of 2. All right. Now, one thing we should note is this one. Remember, this is what we're given. Minus 3 sine 2x minus 3 cosine 2x. This we can write it as what? K sine. Now, this is not x, this is 2x, right? So we're going to have 2x plus, now, as you can see here, plus what? Beta, right? So in the place of alpha, actually, we should be using beta. So it means that this is not alpha, but rather we use what? Beta in place of alpha. So this is all of this should be beta. Here also, this is also beta. 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 Okay. So now how do we find beta? We just follow the same procedure. This is cosine beta. Cosine is negative in the what? In the second, or in the what? In the third. Sine is negative. It's going to be in the third, or in the what? In the fourth quadrant. Now, where is common? What we have in common here is in the third quadrant. So it means we're in the third quadrant. But before we use the charts, we have to use what? We have to look for what? The beta, what we call now the beta star. The beta star will be an angle in the first quadrant whose what? Whose cosine is 1 over root 2 and sine is 1 over root 2. Clearly, that is only pi over 4, which is 45, because cosine 45 is 1 over root 2 and sine 45 is 1 over root 2. So forget about the negative sign there. Now, since we are in the third quadrant, so remember we are in quadrant number 3, right? So in quadrant number 3, you have to use the chart, right? And if you go to the charts, this is our chart here. All right, so it's not showing up, but just hold on. Okay. Oh, we can just draw it here quickly. This is the chart. Here, alpha is alpha star. Here, alpha is pi minus what? Alpha star. And here, alpha is 180 plus what? Alpha star, right? And here, we have 2 minus alpha star. So here, in quadrant number 3, so we will have our beta now is going to be pi plus what? Because we're in quadrant 3, so we will use this one here, which is 180, or you use it as pi plus what? Plus pi star. All right, so it means that beta is just going to be 5 pi over what? Over 4. So what it simply means that we have this one. So we can write the whole of these as what? 3 root 2 sine 2x plus 5 pi over 4. So beta is 5 pi over 4. All right, so let's take one more and the final example here. So example 10. So example 10 is similar to this. Here we can see that we're looking for the A. A is what? A is the period and B is what? Okay. Sorry, the amplitude. If the amplitude of this function is A and the period is B. So first of all, let's just write this function here. Pi sine 2x minus cosine 2x. This should become K and sine 2x plus what? Plus alpha. So, but what is A? Let's take our A to be pi, and B is also what? Is also pi. A is the coefficient of sine 2x. So it means that K is going to be the square root of A squared plus what? B squared, which is just the square root of what? Pi squared plus pi squared. And this is going to be what? 2 pi squared, yes? Now, if you take the square roots, pi will go out. So you have pi root 2 is K. All right. So I think we don't need alpha in this case. So this we can write as what? Pi root of what? 2. Then sine 2x plus what? Plus alpha. So this is it. So now what is the amplitude? Because in this question, A, actually this A here is different from this A. This A, remember, is the coefficient. But we are told that the amplitude is also A. So this A, amplitude A, is just going to be what? Pi root of what? Root of 2, right? Because remember, when you have this one, this is our amplitude, which is there. We can take the absolute value, which is still the same as pi root of 2. Then the period is B. The period B, remember the formula for period is going to be 2 pi over what? 2 pi over K. But now we're not talking of this capital K, right? But this 2 pi over 2, which is just what? Which is just pi. And then we're asked to find A squared over B pi, which is what? A squared is pi root 2 over what? All of this squared multiplying by B. What is B? B is the period, which is this one, which is pi times pi. So I think there's some confusions here about what is A and what is B. So please take note here. This A and this B. So let me use A hat, A star, this one. These ones are coming from the coefficient, but in the question, we are told that the period is B. So that is why I used B here. So take note. Now, this is nothing but what? This is just going to be 2, right? Yeah, because this is pi square times 2 over pi square. This will cancel, and we have just 2. All right, so I think this is enough. In our next video, we'll look at some few more exercises. So share with your friends, and do not forget to like and subscribe. Also, this channel. Thank you for watching.